non-permissible values after you factored are x equals 1 and x equals negative 1. And I always like to take out a different color. When something cancels out, okay, this is going to have a hole at, and the one that cancels out is the non-permissible value of 1. And I like to take the equation and rewrite it in a different color. I choose green. Once that's canceled out, the thing you have to be careful on is sometimes students just say, oh, x plus 1 is the only thing that's left, and they write x plus 1. But that x plus 1 is in the denominator. It has to stay there in the denominator. So just to be careful of that, this is what I end up with. And when I plug in positive 1 into my new green equation, because now this is what I'm going to graph and add a hole. So whenever you have a non-permissible value, that tells you, that cancels out, that tells you there's going to be a hole, and it's at 1 comma, I plug in the 1 into that green equation, and I get 1 over 2 for y. Then we're going to graph the green one following all the steps that we had before. So it still has a non-permissible value at negative 1. That on the green one is still a vertical asymptote at x equals negative 1. The degree is bigger on the bottom. That's the easy one for horizontal asymptotes. That'll be horizontal asymptote at 0. So now, when I go to graph this, I have a vertical asymptote here at negative 1. Horizontal asymptote at y equals 0. Y-intercept is always easy to find, plug in 0. And again, now we're just dealing with the green equation. So I plug in 0 for x, I get 1 for y. And this is why it's important to look at your new equation. Because if you looked at your original equation, you might think there's an x-intercept at 1, because that would make the top equal to 0. But after you've simplified it, my numerator here is never going to be equal to 0. So there are no x-intercepts. So this is what I have so far. And my graph has 2 sections because of that vertical asymptote. And I have no points in section 1. So I'm like, okay, I'd like to add a point in section 1. So I choose an x value in section 1, negative 2. Plug that in, I get negative 1. So I label that point. And that's enough to draw that section. I have a point in section 2, so I don't need any more points. I have enough to graph section 2. And this also, what I've done right here, is very typical. You get to a certain point and then realize, oh shoot, I forgot to put my hole on the graph. So you might have to take out your eraser. Okay. On the provincial exam, usually if you write that you have a hole but you don't graph it, it's a full mark off. So not having that hole on your graph is usually a full mark off. So we need to make sure that, and sometimes, as a good strategy, which I didn't do, but a good strategy that I probably should have done, is when I did my asymptotes, I should have just put a circle and done my hole right away. That way I wouldn't, because that's when I'm thinking about non-permissible values, is when I'm doing my asymptotes. So it would have made sense to do that right away. So today, the plan is just to continue practicing different graphs. There's nothing new to learn stepwise. It's just we might run into new situations in our graphs. So we're just going to get some practice with our graphs, and then we're done our unit. So your take-home quiz, which you got yesterday. Is there anybody not here yesterday? It's going to be due on Monday. And then we can have our test next week, Thursday. So again, this is a smaller unit. Okay, just the one take-home quiz. And really, not very many ideas. This is the, like, for 2.2, 2.3, and 2.4, these steps are the main ideas. I mean, there's a lot in there, but these steps are the key thing. So today we're going to see what are some other little details that might show up. This one is a good example of that because I factor to start with, and the top factor is to x minus 4, x minus 1. And the bottom has a 1 minus x. So this is the algebraic thing. You've seen this before in the past. That if you have a factor like x minus 1 on the numerator, and you have a 1 minus x on the denominator, you can factor out a negative. Because technically, 1 minus x and x minus 1 are not identical. But if I factor a negative out of the bottom, that would make the 1 negative, it would make the x positive. Now, these are the same. So those will cancel out. Now, that means I have a non-permissible value that x can't equal 1. And because it cancels out, I know that it's a whole. And I know that that hole is going to be at 1 comma something. What does my new equation look like now that I've simplified? It's going to be x equals, and a couple of ways you can write it. So I have an x minus 4 left on the top, and on the bottom, the negative's still there, that's a negative 1. Now, dividing by a negative 1, that's the same as multiplying by a negative 1. I'll distribute that negative through. This is easier to work with than having that negative 1 on the bottom. You realize, hey, that's a straight line with a slope of negative 1 and a y-intercept of positive 4. So where's my hole going to be? I plug 1 into that green equation, and I get a hole at 1 comma 3. And now, we graph the green equation. It is no longer a rational equation. It's just a straight line. So you can go, okay, I don't have to worry about this anymore. I'm just graphing a straight line. How do I graph straight lines? Well, first of all, I'm going to do it right away this time. I have no asymptotes, but I do have a hole at 1 comma 3. I'm going to label that hole right away so I don't forget. I know that my y-intercept is at 0 comma 4. I know my slope is negative 1. I can find my x-intercept. At 4 comma 0. Slope of negative 1. And I can draw my graph. But one thing that this question is really good for you guys to see is that notice it started off with a parabola on the top and a line on the bottom. The degree was bigger on the top. That is the situation that sometimes we have an oblique asymptote. And the error that sometimes comes up is students say, oh, it does have an oblique asymptote because it's bigger on the top. That is not the situation here. Okay? You might be tempted to jump to step 3 and think about the oblique asymptote before you've dealt with your non-permissible values and holes and vertical asymptotes. So it's very important that you always factor completely, deal with your non-permissible values, and if you get a hole, that makes a new equation. Do straight lines ever have oblique asymptotes? Did you ever draw oblique asymptotes in grade 10 when you did y equals mx plus b? No. But sometimes we might be tempted to jump ahead before we've done the preliminary stuff. So we always have to check our non-permissible values for holes and asymptotes first. If they are holes, you get a new equation, and that's the equation that determines whether you're going to have oblique asymptotes or not. Okay, so questions to circle on this one. Just number 3.